Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay, tonight we are looking at this question. It comes from Work Energy and Power. It says that a lift of mass 2,000 kilograms, having two passengers, 80 kilograms and 55 kilograms respectively, experiences a friction force of 2,500 newtons while moving upwards. Okay. Then A says draw force diagram showing all forces acting on the lift. Okay. Yes, it's force diagram. So we are representing our object as a box. So what are the forces which are acting? There are some obvious ones, like the Fg, which is always acting downwards. Okay. What else do we have? We have this as our applied force. Sometimes it comes from the motor or it comes from any other force, but it's the one which is responsible for the lift going upwards. Okay, what other force do we have? We have the friction force. Yes, because it was indicated that it is there. Yes, we don't have normal force because the lift is hanging, it's not sitting on the ground. So this happens to be the forces which are acting on the lift. Okay. Then comes this question. The statement reads that the lift is moving at a constant velocity of 2 meters per second through a height of 10 meters. And the question says that calculate work done by applied force or motor. How do you go about this? The best approach actually is to have the free body diagram. What do we have on the free body diagram? We have the applied force, which is Fa. And what else do we know? We know that we have a friction force and we have the gravitational force. And here, what we are going to do, we know that work done by applied force is equal to applied force delta x cos, what angle is that one? We have to remember that this lift is going upwards in the same direction as applied force. So which means that what we have here is cos 0 degrees. Yes, this is the equation which we are supposed to be using. But there's one problem. The problem is that we don't have applied force. It is not mentioned anywhere. So what do? It's like we have to calculate it ourselves. Okay. So how do you calculate applied force? We are going to, the lift is moving at a constant velocity, so we can use this expression which says that F net in terms of force is equal to Fa, because the lift is going upwards, minus Fk minus Fg. But we have to remember that velocity is constant, which means that acceleration is 0. When acceleration is 0, it means that F net is 0 because F net is equal to mass times acceleration. So if A is 0, F net is 0. So if F net is 0, what are we going to do? We put it there, and we say 0 is equal to force applied, which we don't know. But we know Fk. Fk was given us 2,500. And we know Fg. Fg is the same as mg. So coming here, we can say 0 is equal to Fa minus 2,500 minus mass. The mass must be the total mass of the lift and the occupants. So that is it. What we have here is the total mass of the lift and the occupants times g, which is acceleration due to gravity. So here, then we can get our Fa. Yeah, so we get our applied force as this, which is 23,423 newtons. So after getting applied force, what do we do with it? You come and substitute it here. Okay. So you proceed and say work done by applied force is equal to applied force, which is 23,423 times displacement, which is 10 times 1. And what you get here is going to be work done by applied force. So there we are. Work done by applied force is that one. It's 234,230 joules. Yeah. So comes this question. It says that calculate work done by gravitational force. Okay. How do you go about that one? We know that work done by gravitational force is equal to gravitational force times displacement cos. What's the angle? Fg is acting downwards and the body is going upwards. So the angle is 180 degrees. So what do we do here? We know that Fg is equal to mg. And what do we know about our mass? It must be the total mass, which is 2,000 for the lift, plus 80, plus 55, that being the m, times 9.8. Yeah, so we have our gravitational force. And what do we do with it? We substitute it here and we say work done by gravitational force is equal to gravitational force, which is that. Okay, 20,923 times displacement, which is 10 times -1. What you get here is going to be work done by gravitational force. So that is it. Negative 209,230 joules. Yeah, so comes this question. It says calculate work done by friction force. And how do you do about this? Okay, we know that work done by friction force is equal to friction force times displacement cos, what's the angle? Friction force is acting downwards, but the lift is going upwards. So the angle is 180 degrees. Okay. What do we know? We know friction force was given directly, and it is 2,500 newtons. So what do? We substitute it here, and we are going to get 2,500 times displacement, which is 10, times -1. What you get out of this is going to be work done by friction force. So that is it. It is -25,000 joules. Yeah, then comes this question saying, what is the net work done on the lift? Okay. To go about this one, you have to look at this statement, constant velocity. Okay. What does constant velocity mean? It means constant velocity means acceleration is equal to 0 meters per second squared. So if that's true, then you have to recall that F net is equal to ma. So if acceleration is 0, then the implication is that F net is 0. But you have to recall that work net is equal to F net times displacement. So if F net is 0, then it means that work net is 0. Yes. So you see, all these ones are caused by one term, constant velocity. So let me take you through. Constant velocity made acceleration to be 0. When acceleration is 0, then F net is 0. When F net is 0, work net is 0. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences, Silver Bullet. Yeah, we should not forget to remind you to subscribe, to like, to comment, to share. Yes, we are simply the best. Bye-bye.